what we take advantage in this unit is, or what we will, is that we're gonna have two metals that are dissimilar, so they're gonna be different metals. One is gonna be our favorite one, which is gonna be zinc. It's the favorite because we call it the sacrificial anode, and that's how we know what's gonna happen on that side. And then we have another metal that I always like to think about, and this one is gonna be copper. So this one is gonna be made out of copper. If I put zinc and copper together in a solution, if I put them both on the same bucket, they will, and you have something like salt, they will start exchanging electrons. The zinc is going to give its electrons to the copper because the zinc has a higher electromotive force in between them, it's a higher potential. So you have a table, and we'll look at this table in which you'll be able to see that zinc will tend to be oxidized and copper will tend to be reduced. Oxidized zinc will be more likely. If I just connect them, you'll just lose, the electrons will be transferred, but we will not be able to use them. However, if I connect them, and I put a light bulb in the middle, and then the light bulb is there, then in order for the electrons to go from the zinc to the copper, they have to go and turn on the light bulb, or they have to go and turn on your computer, or they have to go, we force the electrons to go through something. We don't break the path, we just make it a little bit more, well, we make it useful for us because we want to use that movement of electrons can actually turn on things for us. So that's what we do. We make these electrons go through a path that we want. The zinc loses the two electrons, right? The zinc loses two electrons, and when it loses two electrons, what happens to a zinc atom? Every zinc atom is gonna lose two electrons. So what happens to it when it loses two electrons? It becomes zinc 2+. Basically, it does what it wants to do. It jumps into the solution and it becomes zinc 2+, which now it is in the most stable form that zinc could ever be. That's what it wants. It wants to get rid of the electrons so that it can jump into the solution. And that's exactly what happens. We do have them in solutions that are gonna help us. This solution is gonna be like zinc nitrate. So we're gonna have some zinc 2+ in solution anyway, with some nitrate in solution. So we have them in a solution, and this one we're gonna have it in a solution that has copper 2+ with nitrate as well. So copper nitrate. So we put some salts in here in order to allow the charges to flow, because we need to have it on electrolytes that would allow the charges to flow. Now, when the two electrons arrive to this side, I had these copper 2+ and the nitrates. The nitrates are spectator ions. We don't really care much about them. But what happens when the two electrons make it to this side? What do you think happens? These are negative charges. They're going to attract the positive copper, right? And they're going to make just regular copper. So every time two electrons come from there, they do that, they come here, and the copper starts just adding over here. Eventually, this side will get a little fatter. It'll just get bigger, right? Because it's got copper added to it. Eventually, on the other side, it's going to erode. Because as the zinc is leaving, then you end up with something that has less zinc, and it's going to erode. And all the zinc classes are gonna be jumping here. So the copper was happy, but because there is a higher potential energy for the zinc to come here, now the copper is not as happy, but now the zinc is super happy because the zinc is got noble gas configuration. The copper is now just solid copper. We connect these two cells, these two half cells of your battery, with something that Vivi called the salt bridge, in which you literally could have sodium chloride Na plus and Cl minus is in solution. And we're not gonna talk much about the salt bridge, but what it does is it completes the circuit. You have a full circuit now. And this area with electrolytes allows it to balance the charges. So this side, zinc is the sacrificial anode. So that side is your anode. And it will get oxidized. It's getting oxidized, it's losing electrons, right? So it's getting oxidized. When you lose electrons, you get oxidized. And the side with the copper is your, whoa. Yeah, we've broken so many. The side with the copper is your cathode. That's where the electrons come to. And this side gets reduced. So the copper gains the electrons and gets reduced. Reduced because the charge goes from positive to a smaller charge, to a negative charge. So that is always true. Now, if you have too many zinc jumping here, this side starts becoming positive, that's not good. And that's the reason that you have your salt bridge. The chlorine will come here and neutralize some of the zinc so that this side remains negative and giving electrons. And the sodium, this side eventually starts becoming too negative because the coppers come here and jump with and making copper, so you end up with these NO3 negatives. So the sodium comes in here and neutralizes the charges of those. So it balances the charges because you want the electrons to want to go to this side that is the one that is more positive. So we cannot have too much positive here, we have to have the positive here. Now, little by little, you start running out of reactants and your reaction is over. So if we were to write this reaction, we'll write my reactants are my zinc plus my copper 2 plus. This is the net ionic equation. And that's gonna give off copper plus zinc 2 plus. So my reactants are the copper 2 plus, the zinc is giving the electrons to my copper 2 plus, and the products of this reaction, you end up with pure copper and the zinc 2 plus that it jumps into the solution. So it is a complex topic. All we need to know right now is how to sketch it, which one is the anode, which one is the cathode, and what happens in the anode. So what happens there?
It gives two electrons.
Losing electrons, right? The anode loses electrons, it sacrifices itself, but I don't know how sacrificial because he's now where he wants to be, right? But it sacrifices by meaning it's losing electrons. What happens at the cathode?
It gains.
Electrons are gained and copper
Forms.
element forms, right? That's all we need to know. If you want to look at the reaction, but when we study this, we'll learn a little bit more. And there is a salt bridge just to balance the charges. That's all we need to know. Again, it's just to introduce this topic.